Welcome to Intercommon Product. This is a special edition in that we're joined by world-renowned and many times esteemed analyst Benedict Evans. Benedict joined us before at Pioneer, where he delivered a fantastic talk about how AI will ultimately eat customer service. Today, we're going to talk about a more kind of general what the hell's going on in the AI landscape, prompted by some of Benedict's recent posts, prompted by some recent changes in AI. But first of all, Benedict, you're very welcome to the show.
Thanks for having me.
Now, we can get straight into complicated ones. The DeepSeek thing caught most people by surprise, but not you. As an avid reader of your newsletter, I think you were on the DeepSeek thing from was it a year and a half ago you were talking about it? How did you pick up that company? What did you make of the last week or so when everyone was kind of caught flat-footed?
So there's several answers to that. I mean, I referenced DeepSeek, I think, last May as one of a new wave of Chinese model companies, because there's probably a dozen of these companies, various kinds of people making these models. I think there's maybe kind of two comments on this. I mean, there's so yes, if you subscribe to my newsletter, you'd have known about DeepSeek in May last year. I think there was a sort of an explosion of comment, and probably far too much comment relative to how important or interesting this is, partly from a sort of kind of slightly weird misunderstanding of quite what it is that they said that they'd done. And then equally a kind of a pushback saying, oh, it's all nonsense, and they just ripped off OpenAI and they just ripped off Meta, which was also kind of missing the point. I think the core issue here is that, you go back to the beginning of 2023 when this has all just started working, and you had a kind of a bunch of primary questions about what was going to happen. And one of the questions was, well, are there only going to be kind of 1, 2, 3 foundation models, or are there going to be lots of them? Because if you went back to machine learning 10 years ago, there was a moment when people said that Google is going to have all the data, and there'll be 3 people will be able to do machine learning. And today, if you were to say how many machine learning models are there, that would be kind of like asking how many databases there are or how many spreadsheets there are. It would be kind of meaningless. And anyone can. And yes, there are some things that are still best done inside a hyperscaler, like kind of generic image recognition or something. You should go to Amazon or Azure or GCP. But, thousands of people are building their own machine learning models for their own purposes. And so that was sort of the question for LLMs, which clearly is, L stands for large. They're very, very, very big. That's why they work. So it's not, you can't run them on your PC now. But are we going to go to a world in which there are dozens of these things? Or a world in which there are hundreds of them, or a world in which there's 3? And I think as a sort of at a deterministic level, this is fundamentally a public commodity technology in which we do not know of any winner-takes-all effects. We don't know of any network effects. We don't know of any reason why everyone will have to use this one rather than that one because of X, in the way that we saw with Google or Instagram or the iPhone. You have to make an iPhone app because everyone has iPhones. You don't make a Windows Phone app because no one has one, and you don't buy a Windows Phone because there are no apps for it. And so, in principle, this is a generic commodity technology, and so therefore there should be a lot of it. And you have to be kind of conscious that something can be very, very scientifically and technically difficult and still be a commodity.
Right. Yeah.
Think of airliners, for example. And so, or TVs. There's an awful bunch of a lot of Nobel Prize winning stuff in a $500 50-inch TV, but it's still $500, and the manufacturer makes $1 on it.
And also, the first person to make it doesn't somehow inherit the rights to the domain forevermore, which I think is something that frustrates a lot of people here.
Yeah, exactly. Apple pioneered the PCs and then lost PCs completely. So we kind of knew, and I was kind of saying, a bunch of people were saying, I don't think it was a very original observation in early 2023 to say, well, that's the question. Are there only going to be, are they going to become winner-takes-all effects, and there'll only be 3 of these things or not? And the answer so far is not. And the day before DeepSeek launched their model, and in fact, the other they started launching models. There are already lots of these things, and you go to LLM Arena or any of the benchmarks, and there's a dozen models that are within striking distance. A dozen companies, probably half a dozen companies to a dozen companies, making models that are in striking distance of the top category. So then DeepSeek put this model out at the end of last year. They've actually, which was also interesting, didn't get very much attention. They've done 2 models that are worth talking about. So first of all, at the end of last year, in December, they did a model that sort of matched what the state of the art in the industry from the summer. So last December, they launched something called V3. And this was the one where the marginal cost of the training run was $5.6 million. It's kind of important to understand that's not the cost of the infrastructure, that's the cost of that training run. They've got, and so since then, a bunch of people come out and said, well, they got something between $500 million and $1 billion worth of compute. And they'd done a whole bunch of other training runs. And so that wasn't like what it cost to make that model. Plus, it's based on Llama 3 and so on. So it's not like that was from 5.6 from zero. But that model launched the state of the industry 6 months earlier. And then 2 weeks ago, they launched another model, R1, which matched more or less the state of the art as of now. So it matched OpenAI's O1 reasoning model, not the O3 research model that no one can use, but the one that's actually in production that you can use. It more or less matches that. And then there's a bunch of yes, but yes, but yes, but. And there's a lot of sort of standing on the shoulders of giants here. And yes, they probably distilled from O3, from O1, and blah, blah, blah. But what this is sort of telling you is, A, you don't need to have a Nobel Prize winner on your research team or to have people who co-founded OpenAI. You also don't need to have $10 billion. You kind of do need $1 billion, which is kind of what DeepSeek has spent. But you don't need 10 or 100. And you don't need to have Jan LeCun or Jeff Hinton or, a whole bunch of you no longer have that very, very narrow constraint in how many people knew how to build this stuff. What we did say, and this is something I said in the presentation, so I do an annual presentation. The presentation I published at the end of last year was like, right now, the only moat is capital. So, and at that point, this was, Anthropic was talking about spending $10 billion to train models. And incidentally, the Anthropic co-founder, Dario, came out and said, after DeepSeek R1 second model, they didn't say what the second model cost. They didn't say what it cost them to get to state of the art. They only gave the cost figure for the one last year. But he said, okay, so DeepSeek trained V3 for 5.6 million to match Claude 3.5. Well, we trained Claude 3.5 for quote unquote low tens of millions. He didn't give an exact number. But it wasn't like that's the point of comparison. It's not $1 billion versus 5.6. It's like 20 or 30 in the summer versus 5 now, which is actually not as dramatic a change as it sounds like after all. So I'm sort of monologuing slightly, but I think all of what the real kind of takeaway is just that people got incredibly excited about this, but all this was really telling us was kind of what we already knew, which is that the cost for this stuff is in free fall, and it's kind of going to be a commodity, and there's kind of going to be dozens of them. And it's not just going to be 3 big American companies.
What's interesting is a lot of what DeepSeek seems to have created is this idea that, hey, so that the value of these things will plummet, to like very, very low, unless it seems like you want to be on the bleeding edge. So it doesn't seem like DeepSeek have created an entire disruptive industry that means that they're going to surpass the state of the industry themselves. It sounds like they're using distillation to actually inherit some of the wins that either Anthropic or Llama or whoever else they're doing. I.e., are they effectively a fast follower with a far, far cheaper sort of cost base?
No. So, well, they don't have a cheaper cost base at all. Yes, technically they might be paying the engineers a bit less, but that's not what's going on here. They had 4 or 5 innovations in how you could fundamentally change the cost. One of which was, distillation is an innovation. It's lots of people do that. But one of the ways they got the cost down is distillation. But there's half a dozen other things that they did too. And that were innovations. So were things that other people hadn't been doing or other people had thought about on audit production. You can also have a conversation about how they're constrained by availability of GPUs. Most of the data center fleet, the training fleet that they have was acquired before the sanctions came in, or at a point where the sanctions weren't really tough enough. But then they can also train on Huawei GPUs. Those aren't as good, but you can get them. You just get more of them. I don't want, in a sense, I think you could really overanalyze DeepSeek in particular. Because all that DeepSeek really did was point to this stuff is a commodity, it's open source, it's going to get really cheap. And going into like the origin story of DeepSeek in particular, to me, isn't really the point. That's all that they tell. That's all what they do is they just kind of demonstrate what we kind of already knew, that it's not just going to be three American companies with hundreds of billions of dollars. Meanwhile, one should point out that in the last week, Meta said we'll increase our data center spend this year to $60 to $65 billion versus I think $29 billion in 2022. So it's up by, they doubled it in 2 years. And they said that after the DeepSeek thing. Microsoft is already on track to spend $80 billion in the 12 months of June. Google, I think, again, increased their number. I can't remember what they increased their number to. Let me just have a quick look. So Google increased their CapEx number for this year. So there's the four big cloud people building cloud. So Google, Microsoft, Amazon's AWS unit, and then Meta. Between them spent about $220 billion building data center last year. And this year, they will probably spend, so there it is. So Alphabet said they'll spend $65 billion this year. Amazon haven't given a hard number for what they think their capex will be this year. But taken all in, they're probably going to spend $275 to $300 billion building infrastructure this year, where in 2023, those same four companies spent 130. So they basically doubled the spend in 2 years.
They're doubling the spend, I assume, to find new edges or new opportunity.
No. So some of this is to have the new cluster to train the new model. Most of it is inference. And so if you go and listen to the conference call from Microsoft and Google, they will say, look, we are behind capacity here. Our capacity is behind demand. The amount of inference that people want to run on our systems is less than we have capacity for. And if you're Meta and you have whatever it is, 3 billion family users across all of their apps, that's a very different capex requirement to if you were OpenAI in December 2022 and you had no users, or September 2022, and the only users were people who work for you. So that's where all this money is going to being able to run these models to provide services to customers. Now, there is obviously a question as to how much that is really pulling ahead of revenue, because right now they're still saying that, they don't have capacity to meet demand, but it's not quite clear where demand is going to settle. And it's also, of course, not clear where the inference needs are going to settle, because part of the DeepSeek point was we can do inference for much less as well as training for much less.
And the challenge, I assume, is is it fair to say that the companies that are training new models are trying to push the sort of frontiers here?
Well, so you have people pushing in two directions, because on the one hand, better performance at the moment still basically just means, doesn't just, but in the end, better performance comes down to more compute. And on the other side, we've got this huge amount of research into getting better performance, which has really meant better compute and more compute with other stuff. And the other side is trying to get the cost given quality of results down, where the cost of any given quality of results has come down by at least an order of magnitude, arguably 2 orders of magnitude. And so there's been this absolute collapse in the cost of what you need to get a given result from a given model, as data center engineering plus science has been applied to the original concept. So you've got kind of people pushing in both directions.
Yeah. It sort of seems like from a distance that it's hard to work out where everyone's going to sit down when the music stops. Like the way I observe it is we have a massive sort of anchor trying to drag the cost, like the end cost of AI down in the form of either open source or in the form of R1 or whatever, where the actual price for a business to use AI is coming down. You have then sort of an uncertainty around what the terminal point of customer demand is. I think the general public are still kind of waking up to the AI opportunity. It's not I don't think it's yet everyone's everyday tool. And then you've a small number of labs, if you like, investing a lot in future models, the price for which is uncertain because of the amount of people kind of following them in the same market. Do I have that roughly correct, or am I still missing something?
So, I mean, we spent a lot of time. So there's on the one hand, there is, I'm trying to think how to put this, sort of a good way of thinking about where we are, that we have this sort of Moore's law of model performance, except that it's not basically Intel, it's half a dozen to a dozen people pushing this forward, both get the cost down and get the performance up. And this is, there's thousands of papers and there's dozens more every day, and you have to be a pretty hardcore machine learning scientist to understand most of them. Just as you need to be, pretty hardcore semiconductor engineer to understand exactly why TSMC does, and what ASML does. Secondly, you have Anthropic and Google and Microsoft and OpenAI kind of giving people prompt and say, here, isn't it amazing? Except it's not one prompt, it's 10 different models, and it does this. And OpenAI and Anthropic both hired Web 2.0 social media people. So OpenAI hired Kevin Weil, who used to run product at Instagram, and Twitter, and Anthropic hired Mike Kroger, who co-founded Instagram. So they hired two consumer product people, trying to say, well, how do we turn this weird prompt thing into something that people can work out what to do with? And the answer for that is most people you look at the data, most people went and look at ChatGPT once. And the number of people, the percentage of people who've looked at it that are daily active users is sort of 2-3%. Most people look at it and say, well, this is very cool. What am I supposed to do with this? So then you have this question of, is that habit? Is that change? And that's very varied by different professions. So software development, customer support, this is what I talked about at your event, software development, customer support, marketing. People look at it and say, yes, I can use this right now. This changes my life. If you're a lawyer, you look at it and you think, well, I don't want something that will tell me what the answer would probably look like. I don't need something that looks like a precedent. I need something that is a precedent. So there's a really wide spread in who can just use the prompt. Thirdly, you have an explosion of companies using the API to build a new product that solves some enterprise software problem where the user never sees the LLM. So you're abstracting this, you're taking this as a new capability, much as you might have taken voice recognition or image recognition, particularly your context, customer support. You don't go to, First Direct and say, hey, would you like a voice recognition API? You wrap it in product. And the same thing, there's now hundreds and hundreds of companies that are taking the APIs from these, or taking Llama hosted somewhere, or even maybe hosting Llama themselves, but they're not giving a user a prompt. They're wrapping it in software and UX and workflow and tooling and processing, and using it as an API call like many other API calls in order to build a product. So you've got those kind of three things that are going on. Sitting across that, meanwhile, there's this sort of philosophical question of, well, how good exactly are these models going to get? Are the models that we've got now kind of basically what we're going to have? And they're going to get better as a matter of marginal improvement, like they'll get 10, 20% better every year. Or are we going to get to a point where you can kind of ask the model to do the whole thing for you? We don't know. We don't, and this is kind of different from Moore's law or from mobile or social or the web. We don't understand the science of how these models work. We know it like a mechanism. It's but similarly, rather like brain science. We know about neurons and synapses and brain cells, but we don't know why we have things that a dog or a chimpanzee don't have. We don't even really know how to articulate what it is that we have that a dog doesn't have, and what it is that a dog has that a chicken doesn't have. We don't really have a good theory of all of that. And we equally don't have we could say, it's predicting the next token, but we don't really know why that produces such good results. And so we don't know what would happen if the model was 100 times bigger. We don't know what would happen. Now, what we kind of know now is, well, we don't have 100 times more data, so we can't make it 100 times bigger. But we don't, for the sake of argument, we don't really know what would happen if you did. We don't have a good theoretical model to explain why these things work. And therefore, we don't know whether these models could get, structure, could, in a kind of a really profound way, 10 times, 100 times better. Because if they did, then they would no longer be dumb API calls.
And then the challenge that creates for, I believe, startups anyway, probably businesses in general, is because you don't know what's potentially coming down the line in terms of new power. You don't really know what shape of product to build. You can either build something that assumes the models don't get any better, and as a result, you build in a lot of like guardrails and a lot of like validation steps and human in the loop and all that. Or you can assume they'll get a little bit better, so you can cast all that aside and just like, put your faith in the model. Or if the models get too good, actually it turns out your product is actually really just a feature on some other bigger product that you hadn't considered that's can be created with like 5 lines of a prompt in theory, like, build me a Salesforce, but it works for dentists type thing. And I think that puts a lot of pressure on startups to like have a strong opinion on a time horizon that they're solving for, knowing that they might end up perfecting the fax machine or whatever, when in reality they were going to get blown away.
Yeah. So, I mean, I'd be kind of slightly cautious about this because, I mean, there's an old English joke about a Frenchman who says that's all very well in practice, but does it work in theory? Um, of which is a lot of truth, actually, particularly in the 18th century. And you can spend too much time sort of philosophizing about, well, what are these things really, and what do they really mean, and where are they going to go? And as an entrepreneur, you don't really want to just kind of sit and say, well, I'm just going to wait 5 years to see what happens, to see how these models change. Well, I've got this idea for what I could do with it now, but I'm not going to build anything because maybe in 3 years, like, it'll all look different. You go and build stuff. And in a sense, all of those companies are a bet that these models will not continue to scale indefinitely. Because if they did, you wouldn't need, the ChatGPT could just do this. You wouldn't need this company to do it for you. ChatGPT could do the whole thing that your company's doing by itself. So they are, in a sense, a bet on that. And the same thing for any big company or, anyone building customer support. Like, do you buy or build the product now that uses an LLM as an API call to do this thing? Or you just say, well, look, in 5 years' time, we can probably just tell our users to talk to ChatGPT, and ChatGPT will talk to SAP and rebook the order. Right. We don't know if that will happen, but you probably don't want to just not do anything for now in case it does happen.
I think like it reminds me of back in like probably when you're a VC, you always heard the common refrain of like, why wouldn't Google just build that? And that became kind of the excuse as to why nothing should ever happen ever. And in practice, people keep building startups. I think like if there's some spectrum on like, and like GPT like 4.0 is like the like, the best it gets on one side, and AGI and full blown autonomous robots and agents that operate desktops is the other. There's some like spectrum here of like, how good will the models get, such that by the time if me and you start a startup tomorrow, let's say we're going to be live in the market in 9 months' time, is it like that you're trying to hit some sort of moving target in terms of what's the right model, or do you think you just go back to like fundamental product assumptions? Is it that enterprise companies don't buy software that quickly, so if you can hit the target this year, you're probably still good for 3 years?
I mean, I think you can probably kind of wind this back a little bit and say, clearly, you just got to go and build software, and you want to deploy stuff. You are going to be a bit hesitant, particularly as a big company. I mean, no big company deploys anything for 18 months. One thing that is clear is that this makes it 20-30% more efficient to write software. And so there are some use cases where people think, well, we might skip some stages and the software might happen quite a lot quicker. But you've got this kind of delta between, well, what does it do now? What might it do in the future? You also have a delta between, it does this great demo, but how do we work out what we could do with that? I mean, again, going back to the last wave of machine learning, the last wave of machine learning starts working with AI, with image recognition. But if you were a customer support company or, reinsurance company, well, you don't have any big images. So what do we do with this? And it turned out that the right way to think about this was pattern recognition. And once you understand its pattern recognition, then you can start thinking, well, what patterns do we have? And even then, there'll be a bunch of stuff where you don't realize that's pattern recognition, or you could turn it into pattern recognition. But at least that kind of gets you to like a good level of abstraction for understanding what this is. And I don't think we have an equivalent level of abstraction for understanding what LLMs are. They can make you text that isn't quite right, but what is it? What is the one-line description of what these things are? And with machine learning, you could draw somebody a neural network, and that didn't help them understand anything. And with LLMs, you can explain that it's predicting the next token, and again, that doesn't really help you understand anything. So the sort of step one is machine learning was neural networks, and this is token prediction. And step two is, it's image recognition. And step two is, it can write poetry, crap poetry. It can write Vogon poetry. And it can say stuff that'll make mistakes. And step three for machine learning, which is pattern recognition. And I don't know what the step three for this is. Like, how do you think conceptually about what it is that it can do? Is it that this just gives you lots of interns? That's still the kind of the way I used to talk about the last wave of AI. Is you can give it stuff that you might give to an intern. You'll have to explain it very specifically, the way you would have to explain very specifically to an intern. They might still get stuff wrong. You won't be able to tell. But that might still be really useful. Where would it be useful for you to have thousands of interns who might get stuff wrong?
When I thought, I mean, I've heard you say that before, and I was trying to reflect on, like, well, the interns are slowly getting smarter. I believe in that. Like, like OpenAI's, say, operator, deep research, they seem to be getting a little bit better, but there is still this like fallibility, like that you highlighted like, asking ChatGPT to find the number of, I think it was elevator operators, and like you ultimately ended up having to basically spoon feed it with PDFs and telling which page to go to and which table to read just to get the actual answer.
Well, it still didn't get it right. That was the point. Even then, it didn't get it right. So you have to be careful about this, because there's sort of two equal and opposite fallacies in looking at any new technology. And one fallacy is to say here are the ways it doesn't work, therefore it's useless. And Telco said this about the internet. Publish your people, and there's a classic interview you can find of all the people who like looked at the web and said it's never going to work. And people always look at the new thing and they always say it's never going to work. The problem is sometimes they're right. And so the analogy I used to give was like, imagine looking at the Wright brothers' first aircraft. It flies like 150 yards. And you look at this and say, well done, you flew over a sand dune. Like, why do we care? It's useless. And you don't realize, yes, but it's a breakthrough principle. And like 5 years later, people are flying hundreds of miles. And you may not realize that this is going to replace ocean liners, but clearly this is like some fundamentally new thing that it's going to scale. It's going to get much better. The other side, though, is look at a rocket pack from the 1960s. Flies for 30 seconds because that's how much hydrogen peroxide you can carry on your back. Guess what? Guess how long they fly now? 28 seconds. Because they made the engine slightly more efficient. But like, if you want to fly for an hour, you're going to need like 5 tons of hydrogen peroxide. You can't carry that on your back. And there was no path for those rocket packs to fly for hours, because there was not like some way that there was that it was, and you knew that when you first saw them. And so the point is, the one fallacy is to look at the new thing and say it doesn't work, and the other fallacy is to say people always say that, because it does. Neither of those statements have predictive value. You have to ask, yes, but is it going to get better? And if not, why not? And all of that is like a long preamble to say, you look at these things and some people will look at them and say, well, look, the models get better all the time. And the problem with that is there are some questions where there isn't, this is the last thing I wrote, there are some questions where there's no such thing as a better answer. There's only a right answer. Now, if you are, if you are in advertising or marketing and you're making images in Midjourney, a better model is a better model. If you're in Hollywood and looking at these video generators, and like the models get better, so you can use them more. And if you're in Hollywood, you might need to make 30 or 40 attempts with a video generator before you get one that you can use. But guess what? You probably shoot more footage than you use as well. Like, you've got a bunch of like actual real live action shots you shot that you can't use. And so there is just a question of percentages. And yes, if the new model, you need to make 10 shots to get one you can use. That's still good. If you are asking it for very, very specific information retrieval questions, then like slightly less likely to be wrong isn't helpful at all. Now, the important thing to understand here, though, is that, and it's kind of another kind of sort of fallacy in thinking about new technology, is the new thing tends to be bad at what mattered to the old thing, but it does something else. So if you were to look at like a bunch of Apple IIs in the late 70s and say, can I use these to replace a mainframe? The answer is no. And even if they get a lot more reliable, the answer will still be no. But they do something else. The same thing with the web. Could you build Photoshop in the web in 1995? No. Can you do it today? Well, it's still kind of, actually you kind of can, but it took 30 years. Meanwhile, what mattered was all the other stuff that you could do with it. And so I think the way to think about these models now is not to say they get things wrong, but that will get fixed. Because I'm not even sure conceptually that it will. Because then what you're basically saying is a statistical model will get to the point that it's 100% right. And that seems to me to be a sort of a category error. But the important thing is to say, yes, but what are all the things that it does where it doesn't matter if it's wrong? Or that's something that's offset by all the things that are the other things it does.
The other side of it is, like even say when we're building Fin, like, an interesting thing we see a lot is people compare Fin not with their human support team, but instead with like perfection. And that's like, it's often, I think people hold a higher standard. Like even in your Hollywood example, you were saying like, hey, you don't forget, you also waste a lot of footage yourself. People generally tend to say like this thing, you know what, there was a slightly better answer that it could have given than what it did give. And therefore I'm going to mark this as a fail. And to which I would often say, have you ever held any individual person on your support team to that standard? The answer is hell no. I don't even know who they are. And it's just, there's a weird thing where like people, I think, are tempted to hold extremely high standards. The other side I notice a lot though is like the skill set for building with LLMs. It starts to look a lot like, just pulling the thread on your infinite interns point. It starts to look a lot like a company org structure when you start to break up the prompts into various different components and have one thing verify another thing along the way. Like so, did this prompt will generate something, this prompt will verify, this prompt will find out, a second source for the same material so we know it's true, etc. And I often, when you look at like how these things are structured, you're like, it feels a lot like this guy fries the French fries, this guy assembles the burger patty, this guy puts the fries and the burger in a bag, the manager sits across and makes sure all these things happen before it goes to the desk. Like humans have we've built org structures to deal with generalizable but quite faulty systems for a long time. And I think it's possible that, as you said, the LLMs never get perfect, but like as we get more and more atomic with what we ask of them, and then build more safeguards in, we actually end up building structures that approximate human reliability, if you know what I mean. So I guess my point is maybe perfection isn't what we're shooting for in a lot of these cases. Lawyers have been known to get things wrong. Harvey has been known to get things wrong. But maybe we'll actually get quite good at building with these smaller components. What do you think about that approach?
So, I mean, I think that we're in a sense, we're kind of rephrasing the issue. Yes, these things have error rates, and so do people. But, if you say to, somebody, go get that document and tell me what the figure for this item is for what it was for 1980, then you would expect them to give you the right number. Maybe another way to think about this is that with a database, it would always give you the right answer, unless there was a bug, which is a separate conversation, which is the UK post office scandal conversation. But the point is that with things like databases or data processing or computers or software spreadsheets in general, they have they do a thing that people are kind of bad at. And they do it very consistently, completely consistently, and completely correctly at massive scale. And so you automate this thing. Whereas what LLMs do, and taking another step in abstraction from that, one of the ways that people describe this is that these are things that people are bad at doing but good at explaining. So it's very easy to explain how you would calculate a mortgage. It's just really hard to do it in your head let alone do it a million times. But it's very easy to explain how you calculate a mortgage. What LLMs and indeed machine learning in general is tasks that are easy for people to do but hard for people to explain. So it's very hard to explain why that credit card transaction is weird. Or kind of go back to the old way of machine learning. Imagine trying to explain to a computer how to recognize a picture of a cat. So you would think that this is easy. Okay, so remember, you've got a grid of pixels. So I'm going to make an edge detector. And then I'm going to make a texture detector. And then I'm going to make some kind of quadruped detector, except that most pictures of cats are sitting down and you can't see their legs. And I'll make something that looks for pointed ears, and I'll make an eye detector, and I'll make something that looks for two eyes closed. And you keep going and going and going, and it always kind of sort of works, but it would never actually work. And it would be like trying to make a mechanical horse. Like theoretically, you can make a mechanical horse. In practice, the degree of complexity is too great and they always fall over. And so then what machine learning does is to say, we'll turn this from a logic problem into a statistics problem. So now we're not trying to explain to the computer how to do it. We're letting the computer work out how to do it, hence machine learning. And so machine learning solves this for recognition, and to simplify massively, LLMs solve it for creation. And so now these things can solve these problems that we find it easy to do but hard to explain. However, they can't do the other things, because they're statistical models. So all of this is kind of a very long way of saying that you shouldn't use an LLM for something that you should use a database for. The reason why it works is because it's a probabilistic statistical model. That's how we got it to work. And therefore, because the things that can actually predictably, reliably produce the same answer each time can't do this, or we can't get them to do this. And so you've got two different kinds of software. You've got software that produces predictable, reliable answers every single time, except we don't know how to tell that software how to recognize a weird credit card transaction. And we've got software that can do probabilistic, non-deterministic things. But they can't answer the same question every time, every way, because they're probabilistic and non-deterministic. And so you've got these two different types of software. And you can't use one to do the other.
No, so I mean, so within, say, Finn, we have an example of like a very common thing. Finn can have a creative back and forth chat, right? Hey, I'm a bit stuck. Oh, what are you stuck with? Well, I'm having a problem with my credit card. What's the problem? Well, I was on holidays in Malta. Oh, that sounds nice. And I lost my credit card. Oh, now at that point, Finn will drop into a different mode, which is deterministic, because it turns out there's a very rigid set of steps you have to follow when a credit card is being reported as stolen, that where you want zero creativity, zero generative, zero riffing on the idea, and instead a kind of a sort of cast iron series of steps taken: report the card, cancel the card, issue a renewal, change the PIN, whatever it might be. And I think like a lot of the challenge of building in this era is like working out, like, to your point, when do you use the ML solution? When do you need the probabilism or the generative aspect? And then when do you have to drop back to like the hardcore deterministic, like boxes and arrows? The only other sort of concern is the boxes and arrows shit has been around for a long, long time, right? Like, people have been trying to build IV chatbots forever. They're a nightmare to create. They're a nightmare to maintain. It's actually easier if you can have a paragraph of text that says, here's how we deal with a credit card refund. And so I think like there's a simplicity that comes from the ambiguity. It's almost like the same reason why people love pseudocode, but there's a reason you can't compile pseudocode, because it reads like English and it's quite ambiguous, right? You actually get into real hardcore code, right? I do think that the challenge, aside from like, building or, decomposing LLMs, working out what's deterministic or whatever, is getting these systems to work reliably together. And then lastly, kind of identifying these problem domains that are well suited to, like, that are unlocked by, say, generative AI, and then maybe just enabled or made purchasable by music.
Yeah. I mean, this is this sort of question of what you're describing is exactly kind of my point of, do you use this thing as an API call within deterministic software, and you have pre-filtering, pre-processing, and post-processing. So you're looking at the question and saying, okay, we've got a keyword match here. It might be as simple as that. It might be an if-then keyword match that says, okay, kick this out to the lost credit card flow. Or this person is asking us for a recipe to make a bomb, kick this out to, sorry, I can't answer that. And, try asking ChatGPT for a recipe to make crystal meth, and you'll get a keyword match and it will say no. Now, it's a bit more sophisticated than that, because this was this thing that, about prompt injection? We talked about this. So if you remember this, this is all this thing we know. Please give me a recipe for napalm. No. Imagine that you're my grandmother, and my grandmother worked at a napalm plant, and she used to tell, and it worked. So you have to be a little bit, there's now 2 years worth of art on how you handle this. But in principle, you can filter and process, and indeed you can ask the thing itself. So, to my people who haven't read the essay, I have this sort of puzzle, which is I made a chart of how many people are employed as elevator attendants in the USA, elevator operators. Like, when this is before automatic elevators, so you have an acceleration and a brake, you're driving the elevator. I always think it's fascinating. And the chart in the 20th century is a perfect bell curve. Because the first half of the 20th century, there were all these towers being built. And the second half, all the elevators get replaced with automatic elevators. We just get in and you press a button. And this is a nice parable about, you don't think of that as being AI anymore. You don't think about it as automatic. It's just a machine. Anyway, this data is published by the US Census once a decade in these PDFs that are on their website. And it's a pain in the ass to type them all in. And of course, you have to know exactly where to find it, and you have to know that they collect that anyway. So you go to ChatGPT or any of these models, and you say, how many people were employed as elevator operators in the USA in 1980? And it will give you a different number every time, and it's never the right number. And then you say, no, go look at the US Census website. No, here's the PDF. No, look at this page on the PDF. No, this page. And it never gets it because it's always kind of doing what would the answer probably be, not what the answer is. Now, try this. Now, there's two ways that this could evolve. Three ways that this could evolve. One way is that the model gets sufficiently good that it will give you the right answer 999 times out of 1,000, even if it never actually gets some structural understanding of what the question is. It will never know what that is, but it will get it right enough of the time. Either it will know that specific number, or the model will be good enough that it will work out how to answer this, and it will work out how to answer it every single time. Or enough times that it doesn't matter unless you have some very, very high fault tolerance, very, very low fault tolerance. Sorry. The second theory is to say that you'll get some sort of emergent structural understanding within the model, and it will sort of understand, quote unquote, which is sort of the path to AGI. We don't see that now. We don't know if that would happen. We don't have a theoretical model for why that would happen, but maybe if the models get much better, maybe that will happen. The third answer is that this is what agents do, and that that the model would somehow know I need to, or step back from agents at a kind of one level of abstraction up. The third answer is that you would have some subsystem within this that would say, aha, I need to go and do a SQL query now. That looks like a query to Salesforce. I will go and ask Salesforce what the answer is, and then I will copy and paste the answer from Salesforce. And so at that point, you're using the agent. The agent is asking a deterministic question to something else. The other view is to say you do it the other way round somehow. And the LLM is an API call within deterministic software. So, for example, inside Salesforce, you have a button that says, suggest me a good answer to this email. And so this is a sort of question is, do you put the LLMs inside the deterministic software so that you can control what's going to them and control what's coming out? Or do you give the LLMs access to deterministic software so the LLM can say to itself, aha, that looks like a deterministic kind of question, I'll go and ask SAP. If I try my elevator question on Claude, it says, that looks like a very specific information retrieval question and I probably can't answer it, which is one of those steps in that process, which is saying that isn't an LLM kind of a question.
Yeah, which is fascinating. And I think ultimately that's there's a system design question there that I think might be tied to what you're trying to solve and might be tied to your risk tolerance. But I think people are genuinely figuring this out. I play with multiple apps across various different B2B domains, some of which are very much, and at this point we shell out to the LLM to apply a cutesy bit of text around the hardcore data we found. And other ones are very much, we've been very generative with our facts and figures, but now here's a deterministic validation step that we want you to take or whatever.
So, think about this as pushing this again, like it might be that you say, I'm going to ask the LLM what kind of documents in our library of PDFs look like good matches for this. It might be that I'm going to ask the LLM, please write me an Excel prompt. Please make me a mock-up of a database query, of a no-code database query. Please make me a mock-up of a dashboard. All the components in the dashboard are being pulled from deterministic software and have labels and descriptions produced by deterministic software. But you're getting the LLM to do the heavy lifting of please build the whole thing for me, but you can then go in and look in and see what it's doing. So you're using the LLM to control the API, the deterministic software. Or you could do it the other way around. You could have like your Salesforce dashboard, which is all deterministic, or whichever software you're using is all deterministic. But you have a button that says use an LLM to answer this question, or use an LLM to fill in a good email for me. Here, you've got this question of how do you mix these two capabilities together?
Yeah. I mean, I'm reminded of and I promise I'll end the conversation here, but what I'm reminded of is say designing for factories. Sometimes you put generalist, i.e. a human or an LLM, in front of a load of buttons. The buttons are effectively subroutines that when pressed, execute a series of steps, stop the conveyor belt to do this, do that, or whatever. That's how you solve some problems. Other problems, you have somebody sitting in a room until a red light goes off. And when the red light goes off, he runs out and does a lot of stuff, right? So that is a different situation, which is a machine is calling a general. And I think both seem to happen. Like, so I think in practice, software will end up seeing solutions from both walks of life. I do want to let you go. My last question, my only kind of question that deviates from this topic. You called DeepSeek earlier. Sorry, you pointed to DeepSeek earlier at a minimum. I think you did do more than that. Are there things you think people are missing right now, or like that you're paying attention to that you find folks aren't seeing right now? Is there stuff in it coming out from an oblique angle that, like, in this space that you think might be relevant across 25, 26?
So, I mean, look, what we're seeing at the moment is that the models are getting cheaper and faster, cheaper and better continuously. We have a lot of people talking about agents, and which we haven't really talked about. And OpenAI launched their Open Research or Deep Research model for 100 people paying $200 a month, which again is this attempt at kind of poking around at more deterministic kind of answers. There's a lot of people talking about agents, but also none of this stuff worked 2 years ago. And so to say, well, where are we going to be in a year's time? It's difficult to answer that, except to say that, computers tend to get cheaper and faster.
And like the implication there is like, well, we might have phones soon running local LLMs, desktops running LLMs.
Well, so we already do. So Apple Intelligence on, the last 2 or 3 iPhone models is mostly running locally. So, the notification summaries and the writing tools. And so people are kind of, one of the ways of getting the cost of the software down is, how much of a model can you fit onto a phone? Because these models are very big, they need a lot of memory, so the full fat model doesn't fit onto a phone. But how much of a kind of a smaller cut down model can you get onto a phone? How good that might be, which is also part of distillation. A lot of the reason people are interested in distillation is you basically get a very small model that's trained off a very big model and gets you kind of 90% of the way there. So yes, we're going to see a lot more people trying to get the models onto the phone as well as another way of trying to get the operating cost down, because that obviously for a developer, if you're using the model on the phone, it's free because it's the user's compute. It's not your compute.
Interesting. So I'll keep an eye out for phones. Benedict Evans, thank you so much for your time today. Really great conversation.
Thanks a lot.